All right, 6.2, multiplying polynomials. So it's going to be a lot of distributing. There's going to be some double distribution, triple distribution. I'm going to show you how to multiply using boxes. And then at the end, we're actually going to do Pascal's triangle to help us do binomial expansion. So a lot of stuff in this one, so let's get rolling. Number one, so to multiply a polynomial by a monomial, just use the distributive property. You also need to use your laws of exponents. So I'm going to distribute here. 3 times it's 1, so that's just 3. X squared times x to the third. Remember, we add the exponents. So that's x to the fifth. And I'm going to get 12x squared. And those aren't like terms, so that's as good as I can go. Next part, now we got 2 variables. So this is really a to the first, b to the first. So, because remember when you're multiplying, you're adding those exponents, so that 1's important. So when I do this first piece, I'm going to have a to the fourth, and then the b is just going to kind of follow. Now I got to go this way, so I'm going to have 3 as my coefficient. A to the first times a to the first is a squared. B to the first times b to the second, b cubed. And finally the last one, I got a subtraction symbol. It's going to be a to the first, and then b1, b3, that's b to the fourth power. No like terms there, so we're all set. So now we're going to move down to where we're multiplying 2 polynomials together. So you basically need to distribute all the pieces from the first parentheses into the second. So some people prefer to use, this is probably the fastest method, is to just do double distribution. So I'm going to take this x, and it's going to get multiplied by all 3 pieces. So x times 1 is x times 3x is 3x squared, and I'll have minus x cubed. And then I got to go to my next number, which is the negative 2, and I got to start multiplying this one through. And I could either stack it or I could just keep on going. I'll just keep going on this one. So that'd be a negative 2. Negative 2 and 3x is negative 6x. And negative times a negative is a positive 2x squared. And then what I want to do is I want to gather up like terms. So there's different ways you can kind of do this, but I'm going to go through, since I want to write it in standard form. I like to get in that habit. The biggest power here is x to the third. So you're going to be my leading term there in the front. So you're gone. Now we got the x squares to deal with. 3 of them and 2 of them. That makes a positive 5 x squared. So you're gone. Now we have the x family. 1x, negative 6x. That's a negative 5x. So you're gone. And then I have the constant, negative 2, just chilling there at the end. So still not too crazy, but a little bit more going on. I'm going to show you a different way on this 3 by 3. So instead of doing all the arrows, and basically there's going to be 9 distributions, 3 for each term, 3 to the back. And you always can know how many terms you have, because there are 3 terms here, and there are 3 terms here. So there's going to end up being 9 terms that you have to kind of gather together. I'm going to do this one, though, in a box. So what I'm going to do is I'm going to draw a 3 by 3 box, almost like a tic-tac-toe kind of Rubik's Cube looking thing. And then I just got to pick the side and the top. It doesn't really matter who goes who. I'm going to do the x squared, positive 3x, negative 5. And then I'm going to have the x squared minus 1x plus 1. And now every row has to get multiplied by every column. So x squared times x squared is x to the fourth. X squared times 3x, that's 3x to the third. This would be a negative 5x squared. This would be a negative x to the third, because remember that's an x to the first. This would be negative 3x squared. This would be a positive 5x. On the bottom, I have 1x squared. I have positive 3x. And I have a negative 5. And now what usually happens, not always, but 9 times out of 10, you can kind of look at the diagonals, and you can combine like terms going down the diagonals. As long as they're both in descending order and they're not missing any terms, you can do it this way. So when I clean all this up, my final answer is going to be x to the fourth. You're the big dog. I have a -1 and a +3, so I'm going to have 2x cubes. Next I have, there's -8 and a +1. That's -7. Then I have 3x's and 5x's, which would be 8x's. And then the -5 chilling, bringing up the caboose here at the end. So there's the correct answer for that one. So some people refer to this as the box method. And some people really like it. So you can do that. I'm not going to do number 3, but if you wanted to use the box method, since you look at this one and you're like, this is a 2 by 3. Those are the dimensions. So you'd want to make your box 2 by 3. So it's going to be a little bit longer of a rectangle. So you'd have the 1, the plus 3x, the minus x squared. Then here you'd have the x and the -2. And you could proceed just the way we did on the last example. But I just want to show the dimensions of your box might be a little different. Now, we can also raise polynomials to powers. This oftentimes is called expansion. So sometimes this is referred to as expansion. And since this is a binomial here, all right, since that piece is a binomial, a lot of people call this binomial expansion. So if I'm going to do this by hand, what I kind of have to do is I'm going to have to multiply this out times itself 3 times. So I'm going to have x plus y times x plus y times another x plus y. And you can't really do all 3 of these at once, so you kind of have to break it up. So I'm going to first do just these 2, the first 2 together. And I'm going to work that out. So just doing my distribution, x times x is x squared. X times y is xy. Then I come to this second part, y times x is another xy. I could have wrote yx, but I like to keep them alphabetical order. Makes it easier for grouping them up. And then y times y would be y squared. And now I'm going to want to clean this up because I don't want to multiply these 4 terms by the last 2, because then I'm going to have 8 pieces, and it just creates more stuff. So I'm going to go ahead and combine like terms here, and I'm going to get x squared plus 2 of those xy's plus y squared. All right. So this right here is basically what this ended up being. But now I still got to go back and I still got to multiply by that third x plus y. And you could put it in the front, you could put it in the back. Doesn't really matter. But what I need to do now is I need to come in here and I need to multiply this x squared by both people. And then I need to multiply the 2xy by both people. And then I got to come in and I got to multiply the y squared by both people. So you may want to use a box if these arrows get a little confusing. Or you could just do the arrows. I think I'm just going to do the arrows on this one. So x squared times x squared times y. Now I move to the middle term. 2xy times x and 2xy times y. Now I move over to the third piece. Y squared times x is xy squared. And then y squared times y is y cubed. And now we got to see if there's any terms that can be grouped together. Well, I think I do have a few. I think I have this x squared y and another 2x squared y. So that's 3 of them. So I have 3 of those x squared y's. And then xy squared family, I got 2 of them and another 1 of them. They look a lot like the term before, but these are xy squareds where these people are x squareds y. So they're a little bit different. So you got to be careful. And then I have the y cubes chilling at the end. Nobody to go with. So this would be my final answer. Now, expansion to the third power, not too bad. If we had to do expansion to the fourth power, we would now have to take this entire expression and do it again. And it would get pretty monotonous by the time you got to the fourth power, the fifth power. So there's kind of a little bit trickier way that's a little faster using what's called Pascal's triangle. So if we go to the next page here, scroll down to the back side. And so binomial expansion and Pascal's triangle, how they're related. So I put one here, y minus 3 to the fourth power. I don't want to do y minus 3 times y minus 3 times y minus 3 times y minus 3 because it's going to be really long. So here's how I can use Pascal's triangle. And here's how it starts off. Pascal's triangle, you start at 1, and then right underneath it, you put 2 more 1s. And now underneath that, I always start with a 1, and then I have to stagger, and I have to add the 2 numbers above me. So since that 1 plus 1 above is a 2, and then I finish with a 1. It'll be a little easier to see once we get further down. Now I'm going to start with a 1. 1 plus 2 is 3. 2 plus 1 is 3, and then I finish with a 1. And I'm going to have 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Finish with a 1. Then I'm going to have 1 plus 4 is 5. 6 plus 4 is 10. 10. 5. 1. I'll do one more row. 1, 6, 15, 20, 15, 6, and then another 1 over there. I might have flew off the screen, I hope not, but there's another 1 there at the end. So these numbers, Pascal's triangle is pretty crazy. If you Google it, go on YouTube. It has a lot of implications with probability and permutations, combinations, that sort of stuff. When you have a certain number of objects and you want to know how many different ways you can arrange a certain number of them. But another application is these things provide coefficients for binomial expansion. And the big thing I want you to understand is this first row right here, this is what's considered row 0. This is row 1. This is row 2, row 3, row 4, and row 5, and row 6. Basically, you can just look at this number, the first number right here, and that will tell you what row it is. So there are the rows. Now, let me show you how that ties in with binomial expansion. So, and it takes a couple times of practice with this to really get it. So first thing I do is I look at this and I'm like, hey, we're trying to go to the fourth power. So what that tells me that I need to go and look at row 4, which is right here. So I want to zoom in and focus on row 4. Those numbers right there are going to help me out. So here's what I'm going to do. I'm going to kind of eliminate these bottom 2 rows just so I have a little more room to work. All right. First thing I like to do is I'm going to write down the coefficients. So I'm going to write down the 1, the 4, leaving lots of room here, and you'll see why in a second. And so I write down the coefficients 1, 4, 6, 4, 1. Well, here's kind of what's going to happen. This first chunk, so I have a binomial with 2 pieces. This first chunk here, I need to kind of distribute that through or write it through all of these. In the very first chunk, you're going to start off by doing y to the 4th power. And then you're going to reduce it every time you move a turn to the right. So I'm going to have y to the 4th, y to the 3rd, y to the 2nd, y to the 1st, and then there'll be no y in the last slot. The y's are used up because there's 5 places there and there were only 4 powers. So you always start with the biggest and work your way down. Now, the other piece, this piece right over here, this -3, that one you're going to do the opposite. You're going to build your way up to 4 at the end. So you're going to end up with a -3 to the 4th over here. And this one will be -3 to the 3rd. And this one will be a -3 squared. And this will be a -3 to the 1st. And you're not going to have any in the first one. So if you notice the first character there, the y, starts at 4 and goes all the way down to nothing. Where the second part, the negative 3, starts at nothing and builds all the way back up to 4. Well, now I got to kind of clean this part up. So I got to do my math. Well, 1 times y to the 4th is just y to the 4th. Well, over here, negative 3 to the first power, well, that's just negative 3. And then multiplying these out, that's going to be a negative 12 y to the 3rd. Well, then my next piece, I have this negative 3 squared, which is just positive 9. And 9 times 6 is 54 y squared. Now, my next one, negative 3 times negative 3 times negative 3, well, that's going to be a negative 27. Negative 27 times 4 is negative 108, I believe. And then finally, negative 3 times itself 4 times, that's going to be a positive 81. And I now have the final answer without having to go through and multiply y minus 3 out by itself 4 times, gather up like terms a bunch of times. This kind of does it all in one step for me. And it's a little bit tough when you first get started, but once you do 3 or 4 of these, it kind of makes sense. But the biggest idea is, get the numbers from Pascal's triangle, they're your coefficients, and then start with this first slot, whatever the first term is in the binomial. You're going to start at this number and work your way down. 4, 3, 2, 1, none of them. And then you grab the second term, and you start from 0, and you start building up. So 0, 1, 2, 3, 4. So let's try another example. Maybe I can make it a little bit more clear to you. So first thing I need is I kind of need Pascal's triangle. So maybe I better just sketch that out again real quick. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And I just needed row 3. Now this is the third power. So this is the row that we're looking for. So this one's only going to have 4 terms in it. So let's spread those coefficients out. 1, 3, 3, 1. And this one's a little tougher because I don't just have x and y, I have like an expression there. So my first part is going to be the 4z, and I got to start at the third power and work my way down. So I got to do 4z to the third power, 4z to the second power, 4z to the first power, and then nothing at the end because it's to the 0 power. Well, then I go to my second term, the positive 5, and I got to start at 0 and start building my way up. So this one's going to be 0. Then I'm going to go 5 to the first power, 5 to the second power, and I finish with 5 to the third power. And now I just got to go through and I got to do my math and tighten everything up. So 4z to the third power. Well, 4 to the third, 4 times 4 times 4 is 64. And that would be z to the third. Over here, I have 5 to the first, which is 5, times, well, 4z times 4z, that's 16z squared. And I got times by that 3. So 3 times 16 times 5, it's what, 240, I believe, z squareds. Now I come over here, I have 3 times 4z to the first, times 5 squared is 25. So 3 times 4 times 25. So that's 300. And those are just z's. And then 5 to the third power, 5 times 5 times 5 is 125. And boom. Now, I'm not saying you couldn't multiply that top one out by itself 3 times and just do it the normal distribution way, but it will be longer. Once you get good at this expansion, it will be a lot longer. I want to mix one in that's a little tougher. So if you have some room on your paper, or you want to grab another sheet, I'm going to actually do a tougher one where you got 2 variables and it's a little more complicated. So 2x plus 3y to the fourth power. So thinking about my table, 1, 1, 1, 2, 1, 1, 3, 3, 1, and 1, 4, 6, 4. So we got to use that row. Since it's the fourth power, I got to use row 4. So let's spread those numbers out here. So 1, 4, 6, 4, and 1. And let's follow our rules. So I take this first piece and I start with the fourth power and I start going down. So 2x to the fourth power, 2x to the third power, 2x to the second power, 2x to the first power, and then none on the last one. Then I come over here to my second piece, the 3y, and I start at 0, so there's nothing in the first chunk. And then I start building my way up. So 3y to the first, 3y to the second, 3y to the third, and then finally 3y to the fourth. And now I got to just multiply every monomial there, every chunk out, and put it all together. So in the front here, 2x to the fourth power, well, 2 to the fourth is 16. And then x to the fourth is just x to the fourth. Now my next chunk, I got to be careful here. This is 4 times 2 times 2 times 2 is 8x to the third. And then times 3y. So multiply my coefficients. That would be 12 times 8 is 96. And I have an x to the third and I have a y in there. Next chunk, I have 6 times 2x is 4x squared. And 3y times 3y is 9y squared. So times your coefficients. 6 times 4 times 9. So 24 times 9 is 250 minus 24. Is that 216, I believe? 240 minus 24, yeah, 216. And it's x squared, y squared. Next chunk is, well, I have 4 times the 2x to the first. 3 times 3 times 3 is 27y cubed. So I got to do 4 times 2 is 8. 8 times 27 is 160 and 56. That's another 216. And we have xy cubed. And then finally, the baby term here at the end, 3 to the fourth power, which is 81 y to the fourth. And this is the polynomial that shows all of that stuff being multiplied together. So, kind of tough. Definitely takes a little bit of practice, but hopefully you're starting to see the pattern there. Pascal's triangle sets up the coefficients. Do the descending and ascending order for the powers for each term, and you should be good to go. Hopefully this gets you ready for the practice. See you.